Hi, welcome to STEM at Home. My name's Mr. Norman. Today we're going to do some experiments and demonstrations of weathering and erosion. Weathering is when the Earth's surface is broken down into smaller pieces. Then those pieces are moved by a process called erosion. The first demonstration we're going to do illustrates a type of weathering that's called freeze wedging. For this demonstration, we're going to need a plastic bottle, approximately 1 liter bottle, some plaster of Paris, a scissors, a twist tie, a mixing bowl, package cutters or box cutter, and a balloon which I've already put water in and tied up. You want to make sure there's no air bubbles when you tie it. The box cutter and the scissors, you will need help from an adult. In addition to the other things, you're going to need an awl, which this is an awl on a multi-tool, and this is an awl on a pocket knife. Or if you don't have an awl, you'll need a hammer and a big nail. And also you'll need something to stir the plaster with, so a tongue depressor or a spoon or some other implement like that to stir with. And of course you'll need access to water for mixing the plaster Paris and for putting water in the balloon. First we're going to have the adult cut off the plastic 1 liter bottle about 6 inches high, so right about up here. Just cut around. And you get something like this, about 6 inches high. The next thing we're going to do is to put a hole in the bottom of the bottle. Now there are a couple ways you can do this. You could do it with a drill. You could do it with, if you have a pocket knife that has an awl, you could use the awl to make the hole. Or if you don't have a drill or a pocket knife, you can use a nail and a hammer. An awl looks like this, and you would take the awl and you would put it in the center of the bottom and you would twist it. It takes a lot of twisting to do it. I'm going to show you the way to do it with a hammer and a nail, since that may be, some of you may not have a drill or an awl. So you would need a block of wood to put inside your bottle to serve as a backing for when we hammer the nail. A fairly big nail. We're going to nail it through. If it gets stuck on your wood, you have to wiggle it back and forth. And there's our hole. And then we take a pair of scissors and take the pointy half of a pair of scissors, and we're going to just turn it around and around and keep going in the hole. Turn it around and around and around. So keep doing the hole until you get to about 1/4 of an inch like this. And that's what we want to have, so we can secure our balloon to the bottom of the bottle. What you're going to do with a twist tie is you're going to go below the bottom of the balloon where you blow it up, and you're going to wrap the twist tie around the balloon at least 3 times. And this is and we're going to straighten out the twist tie like this. And this is going to be so that we can thread our balloon through the hole. And there it comes through the hole. And then what you're going to do is take off your twist tie and put your balloon down on the side so it doesn't fall back through. Take some duct tape. Hold the balloon on the side like this and tape over the balloon so that it holds it. And also this keeps any plaster of Paris from leaking through. We're going to put one more piece of duct tape. Just to make sure there's no leaks. Put another piece of duct tape on there. And now we're ready to mix up our plaster of Paris. So I put down some newspaper so it doesn't make quite as big a mess. And the way we're going to do this is to put a little bit at a time. You can put it all in at once, but then it's very hard to stir. So we'll put about 1/4 of a cup. And then we'll add a little bit of water to it. It says you should have twice as much plaster of Paris as you have water. And then we need something to mix it with. We're using a tongue depressor to mix with, but you can use a spoon or any kind of object like that. Now, I'm not measuring exactly the proportions. I'm trying to get it to the consistency of about chocolate syrup consistency, somewhere between chocolate syrup or fudge. I keep putting in a little bit of water and putting in a little bit of more plaster of Paris. And that's what we're going to keep doing until we get enough to cover the balloon. We want the balloon to be covered in at least as much as it's going to have on the side, so it'll have about a 1/2 inch or 1 inch on the sides. So we'll want to cover it on the top by at least a 1/2 inch or 1 inch. Keep putting more in and putting a little bit more water each time. Once you think you have enough to cover the balloon, we're going to pour it in to the container with the balloon. center the balloon in the container so it's not too near the edges. Now I've finally got enough in there so it's covering the balloon about an inch or a half an inch. So the next step is to let it dry overnight. Now the plaster of Paris is dry, so we're going to put it in the freezer. Take a look at, there's no cracks or holes in the plaster of Paris right now. We're going to put it in the freezer and wait overnight. I've left our container of plaster of Paris in the freezer for a couple of days to make sure that it really froze. And you can see that there are cracks. There are cracks in the side of the plaster of Paris. That's produced by freeze wedging. The water in the balloon, when it froze, expanded or got bigger, and that produced the cracks in the plaster of Paris. This is a demonstration of the process of erosion. Erosion is a process that moves material that has weathered. We're going to need for this demonstration 3 2-liter bottles, and we will need a box cutter, which you'll need grown-up help for cutting the bottles. We also need 3 smaller bottles, which we're going to cut off the top of those. We also need some string. Now we'll also need grass seed and some soil, some topsoil. I've already put topsoil in this bottle and I've already grown grass in it. This will be one of our containers to illustrate how plants and debris can slow down erosion. Also, for this demonstration, you're going to need a nail and a hammer or a pocket knife that has an awl to make holes in the plastic. So we want to take our 2-liter bottles and cut them down. We don't want to go below the mouth of the bottle because we're going to be putting water in here, and we want the water to flow out of the mouth of the bottle. So we don't want to cut down further than the mouth because the water will flow out the side instead of out the mouth where we want it to go. We're cutting 3 of these. One is going to have grass in it. One is going to have litter, like leaf litter in it. And the other is going to be just bare soil. And we're going to see which situation produces the most debris, the most erosion, the most movement of debris into a little bottle. So we're going to hang the little bottles from the edge here, and then to make these little bottles, we're going to just punch a hole in the side of the smaller 12-ounce bottles, chop the top off, get an adult to chop the top off, and get an adult to cut this as well. And then we put a string through and put knots on the ends of the string to hold it fast. The other thing we need to do is to now we're going to put soil in all the containers and put the leaf debris in, and we have the grass already, so we're almost ready to go. Here we have our 3 containers, one with just soil in it, one with leaf litter and soil, and one with grass and soil. We're going to see what happens when we pour in water to simulate rain coming down. It won't be quite as strong as rain probably, but we'll give you an idea of what happens when the ground gets saturated and starts to run off. So here is our soil container. And we're seeing how much debris, soil debris, will run off into the whoa! Overflowed. It was kind of a dam effect. See the cup down there? It's taken on a lot of soil. So a lot of erosion occurred when water was poured on soil. So now we're going to try the leaf litter to see how that fares on eroding the soil away. And as you can see, that cup is clearer than the first cup. So the debris, the leaf litter, kept some of the soil from eroding into the cups. Now I'm going to pour the grass container, pour water on that to see how much debris comes off. So you can see the grass has prevented a lot of the soil from eroding from the ground. The grass has the most clear water. It took away the least amount of soil. The leaf litter took a little bit out, and the soil with just soil took the most